Bismillahirrahmanirrahim. Dr M.yYousaf from the Department of Chemistry, Islamic College, Peshawar is here. Dear student, Assalamu alaikum. Last time I have talked about the reactivity of the carbonyl carbon and aldehyde and ketone. Today we will talk about the relative reactivity of aldehyde and ketones. Relative reactivity of ketones and aldehyde toward nucleophilic addition. So keep in mind the most important reaction taking place in ketones and aldehyde is nucleophilic addition reaction. So generally speaking, we say that ketones are less reactive than aldehyde. Or conversely, you may say that aldehydes are more reactive toward nucleophilic addition than ketones. Now, what are the reasons which make aldehyde more reactive as compared to ketones? There are two main reasons for the high reactivity of aldehyde toward nucleophilic addition than ketone. The first is the steric hindrance. First, I would like to explain what is meant by stereochemistry. Stereochemistry means the environment of the group. So here, the carbonyl carbon, this one, its environment plays a very vital role in the reactivity of this carbonyls toward the nucleophilic addition reaction. The environment in which this carbonyl carbon is present will determine whether it is more reactive or whether it is less reactive. So, by steric hindrance we mean what? Steric hindrance we mean the ability of the nucleophile to approach the attacking center, to approach the reactive site. If this nucleophile it face some sort of hindrance का लफ्जी माना है रुकावट. If the nucleophile it faces some sort of hindrance in attacking this carbonyl carbon, then this phenomena is called steric hindrance. So we have to compare that the incoming nucleophile face more hindrance either in ketone or in aldehyde. So here, if you look over here to the environment of this carbonyl carbon, it is surrounded by two alkyl groups. And remember, these alkyl groups, they are bulky group. Bulky group means they are bigger in size. Therefore, this nucleophile, while attacking on this carbonyl carbon, it will suffer more resistance here, and less resistance here. Therefore, it is easy for the nucleophile to attack on the carbonyl carbon of the aldehyde, while it is difficult for this nucleophile to attack on the carbonyl carbon and ketone. Due to this difficulty in the attack of the nucleophile on the carbonyl carbon of the ketone, we say that aldehyde are more reactive than ketone. Or you may say ketone are less reactive than aldehyde. This is one reason which make aldehyde more reactive as compared to ketones. Right? Okay. Now the other side is the electronic effect. The electronic effect, what is meant by electronic effect? Again, the environment of this carbonyl carbon, will be affected. That is, the reactivity of this carbonyl carbon will be affected by the group which are attached with this carbonyl carbon. That is, the reactivity of this carbonyl carbon will be affected by the nature of the group which are attached with this carbonyl carbon. If some group are attached which are electron donating, so here alkyl groups are attached which are electron donating. How many alkyl groups are attached over here? Two alkyl groups are attached in ketones, and these both are electron donating. These are both electron donating. Therefore, these two alkyl groups which are electron donating, they will affect the charge on carbonyl carbon. Again, they will affect the charge on carbonyl carbon. How? They will reduce this positive charge on the carbonyl carbon, and hence again the nucleophile is coming and the positive charge on the carbon is less due to the electron donating effect of these two alkyl groups, and that's why here the attack will be difficult. Here in aldehyde, you see over here we may have one alkyl group, or we may have a hydrogen instead as an aldehyde. Therefore, here the groups which are attached, one is certainly hydrogen, which is not electron donating, rather it is electron withdrawing. And alkyl group which is electron donating. Therefore, the positive charge here on the carbonyl carbon will not be reduced to that much extent as it is reduced in ketone. Therefore, here the attack of the nucleophile will be easy. So that's why we say that due to these two factors, that is the steric hindrance and the electronic effect, in general, aldehydes are more reactive than ketones, or ketones are less reactive than aldehyde. So based on this concept, now we are having a very simple MCQ related to the relative reactivity of the two compounds, that is aldehyde and ketones. Here is a question. Look over here. Here is a question. Sometime in exam you will be asked which of the following is more reactive toward nucleophilic addition. Keep in mind which of the following is more reactive toward nucleophilic addition. So here we have formaldehyde, we have acetaldehyde, we have acetone. Keeping in mind these two factors, steric hindrance and the electronic effect, this one is more reactive. Look over here, I have drawn here, it is more reactive, followed by this one and followed by this one. So if a question is asked which of the following is more reactive, formaldehyde is more reactive. If the question is asked in the other way, which one is least reactive toward nucleophilic addition, then acetone is the proper choice. So again, steric hindrance सबसे ज़्यादा एसीटोन में है, पॉजिटिव चार्ज सबसे कम एसीटोन में है. दो बातें मैंने की. स्टीरिक हैंड्रेंस सबसे ज़्यादा एसीटोन में है क्योंकि यहाँ पर बल्कि ग्रुप्स है, और पॉजिटिव चार्ज सबसे कम कार्बोनाइल कार्बन पर एसीटोन में है. इन दो अवामिल की वजह से एसीटोन सबसे लीस्ट रिएक्टिव है. अब फॉर्मल्डिहाइड की तरफ आते हैं तो फॉर्मल्डिहाइड में पॉजिटिव चार्ज सबसे ज़्यादा है कार्बोनाइल कार्बन के ऊपर. क्यों? इसलिए कि ये दोनों ग्रुप जो है हाइड्रोजन, ये इलेक्ट्रॉन डोनेटिंग नहीं है बल्कि इलेक्ट्रॉन विथड्रॉइंग है. इसकी वजह से यहाँ पर पॉजिटिव चार्ज कंपैरेटिवली ज़्यादा है। दूसरी बात यह है कि हाइड्रोजन जो है ड्यू टू देयर स्मॉल साइज दे हैव लेस स्टीरिक हैंडल्स एंड ऑल दीज टू फैक्टर दे कंबाइन टुगेदर and this make formaldehyde is the most reactive toward nucleophilic addition and acetone the least reactive toward nucleophilic addition in these three examples.